everyone, welcome to the second session of our Math Olympiad training camp. Today we're going to learn the distance problems. Let's see. Actually, it is a kind of problem which is closely related to our life. First, we need to know its three basics, including how far you travel, which is called the distance, and how long it takes. So it is called as time. And how fast you travel, which is described to be speed. And for distance, we usually use km, kilometer, m, meter, cm, centimeter as its unit to describe how far we travel. And for the time, we usually use hour, h, minute, min, min, and s, second, to describe how long it takes. And the second, for the speed, we usually use km per hour or meter per second to describe how fast we travel. Now, let's see an example. If we know that it takes Rina 15 minutes to walk from her home to Think Academy, if she always walks 200 meters every minute, how far is her home from the Think Academy? So actually you can see if I can walk 200 meters every minute, that means how far can I travel in 2 minutes? We need to add another 200. Continue to add 200. There are 15,200. So actually to find the distance from my home to Think Academy, I just need to multiply the time I spent by how far I can travel in 1 minute. That is called the speed, which is s. So time times speed equals distance. Here we can get it should be 200 times 15 minutes equals 3,000 meters. That's it. So between the three basics, the relationship is distance equals time multiplied by speed. Speed means how far you can travel in one unit of time. Why do you have speed? Sometimes when we want to compare how fast do you travel, for example, when Rina travels 3,000 meters in 15 minutes, and Batu, he traveled 6,000 meters in 20 minutes. If so, can you decide who is faster? It's just so easy to know that. You can see, actually, I spent less time. Can I say I am the first one? But because Batu travels a longer distance, so when both time and the distance are different, it's not that so easy to compare who is faster. That's why we try to make sure one amount is the same, which is the unit. We just compare how far they can travel in 1 minute. 3,000 divided by 15 equals 200 meters per minute. This is how far I can travel in 1 minute. And for Batu, that is 600 meters divided by 20 minutes. We can get 300 meters per minute. Now, if the time is the same, we just need to compare the distance. So we give it a new name, which is called the speed. And to find the distance, we need to multiply time by speed. If you want to know the speed, like this question, you just need to divide distance by time. Later, if you want to find the time, when we know the speed and the distance, we just need to do another division. As long as you know two of the three amounts, you can find the other. That is the relationship between the three basics. Now, let's see how to solve the first question based on what we have learned. Edison left town A at 2:30 p.m. and drove towards town B at 60 kilometers per hour. When you see per hour how far it travels in 1 minute, that means this is the speed. At 3 p.m., Jason also left town A and drove in the same direction as Edison at 75 kilometers per hour. What time did Jason catch up with Addison? That is a question. So actually, you can see there are many amounts, and the relationship is a little bit tricky. In this case, we had better draw a diagram. When we draw the diagram to show the relationship visually, we need to follow some principles. The first principle is different people at a different layer. What does this mean? Because there are two people, both of them are traveling. So to compare their distance, we have better put them in different layers, in different rows. If I put Edison in the first row, I will put Jason in the second row. And as you can see, they start from the same place. So the left point should be aligned, should be in the same column. But in the first time, only Edison is traveling. So we should just draw Edison's distance first. For this distance, it takes him how long? We need to find it. 3 p.m. minus 2.230 p.m. We can get it takes him 30 minutes. We had better put the time over the distance. It can remind us directly. Second, then Jason also starts to travel. But for this time, for this duration, both of them are traveling. So we need to use the second principle of drawing a diagram. Different slots. Using different colors. When both of them are traveling at the same time, we can consider it as a different duration and then use a different color to represent it. When you see different color, you know during that time, both of them are traveling. That's it. Because finally, Jason catch up with Addison. That's what we need to ensure the right points are also aligned. Now, let's see. To make it even more clear, we had better put their speed over the name. Addison travels at 60 kilometers per hour, while Jason travels at 75 kilometers per hour. In the diagram, you can see at once. Actually, Jason has traveled a longer distance than Addison during the second duration after he starts to travel. And the distance difference is just the distance Addison travels in the first 30 minutes. To find the distance, we need to use speed times time. So you can see Addison's speed is 60 kilometers per hour, and he travels 30 minutes. The unit is different. We need to make them the same first. 30 minutes equals 0.5 hours. So multiplied by 0.5 hours, we can get the distance difference is just 30 kilometers. Now, after we know the distance difference, to catch up with Addison, actually, Jason travels a longer distance per hour. Let's find the speed difference. How further Jason travels in 1 hour? We can get it directly. It is 75 minus 60 equals 15 kilometers per hour. When we know the distance and the speed, we can find the time by divide the distance by the speed. Because distance is the difference, so speed should also be the difference. In this time, we can get 30 divided by 15 equals 2 hours. It takes 2 hours for Jason to catch up with Addison, and he starts at 3 p.m. So when he catch up with Addison, it is already 5 p.m., which is option B. Have you got it? Now let's see the second part. Try to use the method we have learned to solve it. Grace and Paul join a marathon together. They start at the same time beside each other. So in other words, they start from the same place. Grace runs at 6 kilometers every hour, and Paul runs at 8 kilometers every hour. After how many minutes will Paul be 5 kilometers ahead of Grace? Now let's see. Still, we need to draw the diagram at once. Different people at different layers. So Grace and Paul should be put in different layers because they start from the same time and the same place. So the left points should be aligned. And we know both of them are traveling. But Paul travels faster, travels a longer distance every hour than Grace. So finally, after they travel the same time, Paul will travel a longer distance. We want to know when the difference between their distance is 5 kilometers. How many minutes does that take? So let's see. Actually, in the picture, we have already got the distance difference. Also, we can label the speed over other name. In this way, we can find the. Actually, we just need to know how further Paul travel than Grace in 1 hour, which is the speed difference, equals 8 kilometers per hour minus 6 kilometers per hour, which is 2 kilometers per hour. And if we want to know the time, we need to use distance divided by speed, which is 5 kilometers divided by 2 kilometers per hour equals 2.5 hours. But the question wants us to describe the time in minutes. So if everybody knows an hour equals 60 minutes. To get 2.5 hours, we need to multiply by 60 minutes. It is equal to 150 minutes. That's it. So D is the correct option. Hope you really got it. Next time when you see distance problem, please remember to draw the diagram to analyze the relationship. Hope you really get it. See you next time. Bye.